try to do question number 11 and 12. We'll start with the new topic once we come down physically after the exams. So for question number 11, what is the total number of possible fault sites? The question asks you what is the total number of potential fault sites. So you will simply calculate the number of nets. Number of faults will be twice of it, right? So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then 12, 13, 14, 15, 16, this is the same, 17 and 18. According to me, there are 18 possible fault sites. Every fan out needs to be considered. वो तीन count होंगे. So total number of potential fault sites is 18. Total number of potential faults, stuck-at faults, will be 18 into 2. Every wire may have 2 stuck-at faults. So 36 single stuck-at faults possible to be considered for this given circuit. Now derive the equivalence collapsed set. We have the AND gate, the NOT gate and an OR gate. तो इन तीनों के लिए कोलैप्स सेट क्या होता है? AND गेट के लिए इनपुट पर स्टक एट 0 गेट्स एलिमिनेटेड and we are left with output stuck at 0, output stuck at 1, inputs stuck at 1. So AND gate का collapsed set is stuck at 1 at inputs, stuck at 0 and stuck at 1 at output, right? तो जितने भी AND गेट्स है उसमें इनपुट पर केवल स्टक एट 1 कंसिडर करेंगे और आउटपुट पर स्टक एट 1, स्टक एट 0 बोथ. Because stuck at 0 at input gets collapsed due to equivalence with stuck at 1 at output, right? So कितने हो गए ये faults? नॉट गेट के लिए सारे ही कंसिडर नहीं, नॉट गेट के लिए एक एक कंसिडर होता है. Stuck at 1 and stuck at 0 at output. और OR गेट के लिए stuck at 0 at input, stuck at 0 and stuck at 1 at output. तो कितने हो गए सेट? नॉट गेट के आउटपुट पर stuck at 1, stuck at 0. Either be 3 or 4 wire. Here you will consider the fan out as well. So stuck at 0, stuck at 1 at 3, stuck at 0, stuck at 1 at 4, stuck at 0, stuck at 1 at 5 due to fan out. Right? इसमें से नॉट गेट आ गया वायर 4 पर. So the stuck at 0 and stuck at 1 fault at wire 4 will be collapsed. So we will eliminate these two and we will only consider stuck at 0 at wire 9 and stuck at 1 at wire 9. ठीक. ऐसे ही ये wire 5 वाला stuck at 0, stuck at 1, this goes to the AND gate. So AND gate पर stuck at 0 at input is eliminated. So we will eliminate stuck at 0 at input of this AND gate. Fine. Work out quickly what is the total number of collapsed faults we have. एंड पे स्टक एट 0 हट गया, इधर से भी स्टक एट 0 हट गया, और पर स्टक एट 1 हट गया, इधर से स्टक एट 1 हट गया. That is all the collapsed set. So how many left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 faults are left according to me. So collapse ratio will be 20 upon 36. Fine. After that, follow the dominant set in the same way. Reduce further number of faults. ठीक. दो सर्किट अलग अलग बनाना आंसर के लिए, one for section B, another for section C. Do not do on the same. Similarly, look at the next question. Leave part A, but if it is asked to show that the two faults D stuck at 0 and G stuck at 1 are equivalent. So any two faults are said to be equivalent if their test pattern are the same, exactly the same. So find out the test patterns which will be able to detect D stuck at 0 here and then G stuck at 1. If the two agree, if the two are same, the faults are equivalent. Similarly, the question may come to prove if the faults are dominant. Say G0 is dominant. तो dominant के लिए क्या चेक करना है? F1 और F2 अगर दो फॉल्ट है, दोनों का सेट्स निकालो टेस्ट पैटर्न का. If one set of test pattern is a subset of another fault test, then the other fault is said to be dominant. So all the tests of F1, if they are able to test F2 as well, so F2 is said to be dominant and we eliminate F2. अगर F1 detect हो गया तो F2 by default detect हो जाएगा. Right? There will be one question in your midterm on this fault equivalence and dominance collapsing. Right? Then there will be a question on simulation. One question on simulation, any of the four types, serial, parallel, deductive and concurrent, कोई भी एक आएगा. And then there will be a question for ATPG generation. These are the questions from Bushnell. Question number 4.9. For an exclusive OR circuit, you may be asked to prove if C stuck at 1 and F stuck at 1 are equivalent. So again the same way. Simply find the test pattern. If the two are equal, we say they are equivalent. Practice these questions. Then comes the second chapter. The input test pattern is given to be 1, 1. So the fault list of A will contain only stuck at 0 fault. So fault list of A, you will write it like this. Fault list of A consists of A stuck at 0. Now the next wire would be the second primary input B. Since the input value of B is 1, so the stuck at fault is B0. Now move further, since this is a fan out, so you will simply say LC. The fault list of C will contain the faults at C. Actually value क्या आएगा, ये 1 है तो ये भी 1 रहेगा, ये भी 1 रहेगा. So it is only C0 which will be added. Union, इसके साथ और क्या आएगा, जो भी B का fault list है, because this is a fan out, so union fault list of B, which is giving you C0, B0. Then fault list of D. D पर क्या fault हो सकता है, 1 is the actual value, so the only possible fault is D0. Union from the fan out the fault list of B. So LD is nothing but D0 and B0. Then you will write it for E. E का actual value is 1. So the only possible fault on E is E0. Plus this will be fault when either of the input goes 0. So either of the input goes 0 means union. और लगाएंगे हम तो union. तो fault list of A union fault list of C. So you will simply write fault list of E is set of all E stuck at 0. Fault list of A union fault list of B. Right? Fault list of A is A0. No, B नहीं C. Or C is B0 C0. So A0 added, B0 added, C0 added and E0 added. Right? This is how you will write for deductive fault simulation. For concurrent fault simulation, simply write the fault list in the form of, say, inputs and outputs. No need to make all these logic gates. Simply write the fault as a set of inputs, comma, set of output. If it is eliminated in the next pass, simply make a cross over it. So for concurrent fault simulation, if the input set is 1, 1, input test pattern is 1, 1. So the actual input is 1, 1 and the output will be 1. So what are the possible faults that it can have? A may be stuck at 0. So if A is stuck at 0, the first fault for gate G1, where I identify this as G1, the fault A0 is simply written as 0, 1, 0. क्योंकि A 0 हो गया, B 1 ही है, so E will give you 0. So the first fault in the list will be A0 colon 0, 1 comma 0. What will be the second fault? A may not be at fault, but B may be at fault at 0. So B0 is the next possible fault. Input will be 1, 0, 0. Right? C is again actually 1. So the possible fault is C0. So C0 may be 1, 0, 0. And lastly, E ka actual value is 1. So the last possible fault for this gate is E0, which is actual value is 1, but output is stuck at 0. So the four list fault at G1 are given like this. Okay, similarly for G2 and G3. No theory questions this time, but in the end term you will have some conceptual questions. For example, what is the advantage that we obtain for concurrent fault simulation when compared to deductive fault simulation? तो deductive fault simulation में हम net पर काम करते हैं. Every net need to have a fault list generated. But here the number of the logic gates are considered. So we consider the fault list at each logic gate. So the number of faults that need to be studied here is less. However, the fault list itself is quite complicated because now we have to specify the inputs as well as outputs. Deductive fault simulation में हमें input output नहीं देखना होता, ठीक है? And lastly would be the chapter 6 is SCOAP. तुम्हारा कितने का होता है मिड-टर्म? 15 मार्क्स का, 20 का ना. सो फोर्थ क्वेश्चन विल बी ऑन स्क्वाप मेजर्स. Swap measures is chapter 6. The question will be simply like this. Question number 6.8. Some figure would be given to you. I think I have uploaded the tube sheet as well. There are some problem in the tube sheet. We'll check that. So you will be asked to write the observability and controllability for the wires. Question number 6.2. A simple circuit given to you, you will be asked to find the controllability and observability. So first always start with controllability. From primary input towards output, initialize all the primary inputs to 1, 1 and then start using the formula. That is very scoring. First sessional would be very scoring. Moreover, it is online. Second sessional तो hard ऑफलाइन है, बट प्लीज प्रैक्टिस. यू आर नॉट एबल टू फाइंड एनी क्वेश्चन ऑन द इंटरनेट, तो ये मत सोचना वहां से हेल्प मिल जाएगा. सो यू नीड टू प्रैक्टिस इट वेल हियर. ठीक है. एनी प्रॉब्लम, स्पेसिफिक प्रॉब्लम? हाँ. क्वेश्चन नंबर फिगर 4 फ्लिप फ्लॉप्स लगे हैं उसमें. इन्फिनिटी से. बी को, अच्छा, बी वुड बी इनिशियलाइज्ड विद 1 1. The controllability will be initialized with 1 1. All the other C और E जो दूसरे flip flops के, that would be infinite. इसमें भी कुछ दिक्कत है, मेरा स्टेबल नहीं आ रहा है वैल्यू. एटलीस्ट 3-4 साइकिल्स तक तो नहीं आ रहा है. हाउ मेनी साइकिल्स इट विल टेक, आई डोंट नो. बट दीज क्वेश्चंस आर जस्ट फॉर प्रैक्टिस. For the time being, you can work with the combinational controllability and observability only. Leave this sequential. बाकी तीनों क्वेश्चन हो गए. और किसी में कोई दिक्कत? एक में किसी में फॉल्ट मेंशन नहीं था, सेकंड वाली ट्यूट शीट में, थर्ड में. इसमें तो मेंशन है, इसमें था. ATPG वाले में थर्ड क्वेश्चन. अच्छा, take D stuck at 0. Question number 3 वाले में, it is simply mentioned that you have to perform ATPG for stuck at 0 fault on the circuit, but it is not mentioned on what wire the fault is. Let's take it as D. One fault at a time. That means you have to work for 2 faults differently. 2 क्वेश्चन हो गए ये एक तरह से. ठीक है, that is all from my side for today. Tomorrow also we'll take up the problems, and day after tomorrow during the class time there will be quiz. I will not be taking the class on square measures. So during the class time only. I'll start the quiz at 9:15. We'll close it by 9:30. Anything anyone wants to add? Okay, so that is all from my side. You may leave.